These past few months, I've been really busy prototyping and designing and testing the trickbox that I'm planning to release. And I loved watching Martin's streams in the meantime while I was playing. Working in the workshop. In one of his streams, Martin mentioned he needed help fabricating some parts. And as I was already stuck in my trickbox design for 2 weeks on a really difficult problem, I thought maybe I should do something else for a little time. So what he was asking for was a bunch of axles for the clock escapement mechanism. And this would be a bit of repetitive work, but I didn't mind that honestly at the moment. I could use something to like clean up all my work area from all the trickbox dust and get a fresh start in my head. These axles will be used in all the marble gates going towards all the different instruments. I can't wait to see them all working at the same time. It's a real pleasure to do something simple from time to time. Just throw your challenging projects aside, clean up your work area, give everything a fresh coat of oil, and start something new. At first Martin was asking for mild steel axles, and after a little chat with him we changed it to silver steel, as I think it's much better suited for the purpose that it's gonna serve. One of the biggest reasons why I advise Martin to go with silver steel is that it has already a surface grinded finish when you buy it, so it has a really accurate dimension, giving it a nice fit. Another reason is that it is quite a bit harder than mild steel, giving it more wear resistance. And I believe it's also a bit more corrosion resistant. A downside using silver steel is that it is quite a bit harder to machine. One of the things that might be a little bit challenging about this project is making the 0.5mm and 0.7mm grooves in the shafts. I was at first going to look at carbide inserts that I grinded down. I had already a few, but not of the right dimensions. And because I needed to make a lot of them, I kind of wanted to make a tool which I could use to both make the grooves and also cut the material off without having to swap tools. And so I decided to instead go with high-speed steel instead of inserts, because if I was afraid that if I would make the tungsten too long, that since tungsten is pretty brittle, the long tips would break off pretty easily when I was using it. So high-speed steel should be a little bit more springy and not break as fast. And of course, like always, you try to aim for a certain number and get as close as possible, and the last time you overshoot it by a lot.
Ach mensen.
Here I'm rounding the tip of the tool just a little bit to get rid of the burrs from the grinding and to make the tool a little bit more durable. I'm definitely not an expert yet in this whole machining area, but I try to read up upon it, follow advice that I get from people, and just apply logical thinking. And most of all, just do it and see if it works. As the tip of this tool is so thin, I wanted to make sure that it is seated perfectly straight and not twisted in any sideways direction. I was really afraid that if it would cut just a tiny bit sideways, the tip would start walking sideways in the workpiece while the tool stayed still, and then it would break off your tip. With the new tool fitted, it was time to align the vertical height of the tool. I'm using this tailstock center to align my height with the point of the tailstock. I'm setting the tool perpendicular to the milling axis using setup blocks. And here we can finally start making our first cuts. Here you can see that I can use the tool for both groove making and cutting of the part without having to change tools. Not only is this faster, but it also prevents me from having to recalibrate every time I swap the tool out. That looks pretty good to me. And the best part is, our tool survived too. Test fitting a circlip seems to work too. I could finally start making the parts. And when I was starting up the manufacturing, I directly noticed another challenge. When cutting the grooves in the other side of the part, it would make this sound. And beside the sound, it left a really rough finish on the part. Because on one side the part is sticking out a long way, it starts to resonate when touching it with a tool. I thought I could maybe fix this with a rotating tailstock center, but I wasn't sure about the force applied while you're trying to cut off a part this small. I called up my dad, who is an antique clockmaker, and he came with the same solution, but using a hollow tip in the tailstock. And using this, it worked perfect, and I got rid of all the resonance. And here I present to you all the steps needed to make one of the 37 axles. Guided by this peaceful music, which this part will probably help recreate in the future.